where flight controllers had expected to be working with their Russian counterparts at the Russian Mission Control Center across the ocean outside of Moscow in the town of Korolev to support another Russian spacewalk today by Russian cosmonauts Sergei Prokopьев and Dmitry Petelin. However, just 10 minutes ago, Russian flight controllers decided to abort the EVA. They have called off today's spacewalk because of a late breaking problem that developed with a backup ventilation unit, a pump in the ventilation unit for Sergei Prokopyev's spacesuit. The two cosmonauts for Roscosmos, Prokopьев and Dmitry Petelin, had planned to exit the Poisk airlock for what had planned to be almost a 7-hour spacewalk to monitor the movement of a heat-dissipating radiator from the Rassvet module through the use of the robotic arm that was to have been operated by cosmonaut Anna Kikina from a workstation inside the Russian segment of the International Space Station. That radiator was to have moved from Rassvet to be attached to the Nauka multipurpose laboratory module, and then to be followed in turn on December 6th by the movement of an airlock, an experiment airlock on Rassvet, to the Nauka module itself. Both the radiator and the airlock had been launched 12 years ago on the STS-132 mission of the Space Shuttle Atlantis. The two cosmonauts had spent the last several hours suiting up for the spacewalk. They had gotten to the point in their timeline for pre-spacewalk preparations where they were going to do systems checks and then climb inside the airlock itself to depressurize the airlock and open up the hatch to begin what would have been the 256th spacewalk in support of space station assembly, maintenance, and upgrades. But about 40 minutes ago, Prokopьев reported that a pump, a backup pump, one of two redundant pumps for the ventilation unit in his suit, was not operating properly, not providing the proper cooling for his suit. And as a result, the two cosmonauts got out of their spacesuits, their Russian Orlan spacesuits. They did inspections. They disconnected and reconnected cables that connect the ventilation unit to the liquid cooling garments for their Orlan spacesuits. They climbed back in to those spacesuits, fired up the pumps once again. The primary pump on Prokopyev's suit was operating normally, but the backup pump would not. And as a result, the Russian flight controllers in Korolev at the Russian Mission Control Center decided just about 13 minutes ago to call off today's spacewalk. So there'll be no spacewalk today. That information was relayed from the Russian shift flight director in Korolev to our flight director here in Mission Control, Fiona Tourette. And we are now in the process of replanning the timeline for the crew's day today. There is no indication at this early juncture as to when this spacewalk might be rescheduled for. There's a great deal of activity that lies ahead in the coming weeks on board the International Space Station. The next series of U.S. spacewalks are planned for December 3rd and no earlier than December 19th, when the next two ISS rollout solar arrays to be launched on the SpaceX Cargo Dragon from the Kennedy Space Center in Florida tomorrow. Those two IROSAs, part of a complement of food, fuel, supplies, and scientific experiments to be carried aloft on the Cargo Dragon. Our coverage of that launch tomorrow from the Kennedy Space Center and Launch Pad 39A will begin at 2 p.m. Eastern Time for a launch at 2:20 p.m. Eastern Time. That would put Cargo Dragon on a trajectory to reach the International Space Station for a docking on Sunday. The docking is scheduled for 7:30 a.m. Eastern Time on Sunday. Our coverage on Sunday to begin at 6 a.m. Eastern Time. These two solar arrays, one for the 3A power channel on the starboard foretruss and one for the 4A power channel on the port foretruss of the International Space Station, again to be installed on the next two U.S. EVAs on December 3rd and December 19th.
Copy. It's been a pleasure to talk to you. And we'll meet again, I'm sure. Good luck to you guys. The moment we have anything planned, we're going to let you know. Copy. Thank you.
Сергей, Дмитрий, Аня, спасибо огромное. До встречи.
Sergey, Dmitry, we'll talk to you soon. Talk to you soon. Thank you.
So as you just heard, the Russian flight controllers telling Sergei Prokopiev and Dmitry Pitelin that it was unfortunate that they could not conduct their spacewalk today. Again, just to recap, preparations had been going along smoothly for the start of the spacewalk that had been planned about 30 minutes from now. It was to have been about a 7-hour spacewalk for the two cosmonauts to monitor the movement and then connect a radiator that is housed on the Rassvet module of the International Space Station on the Russian segment. It was to have been moved robotically by cosmonaut Anna Kikina using the European robotic arm. It was to have been detached from the Rassvet module and then robotically moved for attachment to Nauka. That, along with the subsequent movement on the next spacewalk by Prokopiev and Pitelin to watch the movement of an experiment airlock currently housed on Rassvet over to Nauka. Those two activities would have put those two pieces of hardware on the multipurpose laboratory module for use in the future. However, about 40 minutes ago, Prokopiev reported a problem with a backup pump for the ventilation unit in his Orlan spacesuit. There was some troubleshooting conducted by the cosmonauts, but it was to no avail, and Prokopiev could not bring that backup pump into operation. The primary pump was working, the backup pump was not. And so flight controllers in Korolyov at the Russian Mission Control Center elected to cancel today's spacewalk. There is no new date at this point for this spacewalk to be conducted.
For Anna, for space to ground 2.
So with the cancellation of today's spacewalk, again, no new date has been scheduled for the next excursion by Prokopiev and Pitelin. This was to have been the fourth spacewalk in Prokopiev's career, and the second for Pitelin, the 256th for space station assembly, maintenance, and upgrades, but that will not be the case today. No spacewalk for the two cosmonauts due to a ventilation cooling problem with Prokopiev's suit and the pumps that operate that cooling system in his Orlan spacesuit. So with that, we will wrap up our unexpectedly abbreviated coverage for today. Once again, today's Russian spacewalk 56 to monitor the movement of a heat-dissipating radiator from Rassvet over to Nauka, with Sergei Prokopiev and Dmitry Pitelin all set to conduct that spacewalk outside of the International Space Station. That excursion has been canceled for today due to a ventilation problem in the cooling system of Prokopiev's suit. No new date for this spacewalk has been scheduled as of this time. So we'll point you again to our coverage tomorrow for the next operational activity on the International Space Station, that being the scheduled launch of the SpaceX Falcon 9 rocket and the Cargo Dragon that will carry tons of supplies, scientific experiments, and the next two ISS rollout solar arrays for installation on the power channels of the International Space Station. That launch is scheduled for tomorrow, Saturday, November 26th. Our coverage on NASA television beginning at 2 p.m. Eastern Time for a launch at 2:20 p.m. Eastern Time. So come on back with us tomorrow for coverage of SpaceX and, of course, our ongoing coverage later today of Orion's mission on the Artemis 1 flight. The Orion spacecraft's distant retrograde orbit insertion burn. Our coverage, our live coverage on NASA TV this afternoon is planned for 4:30 p.m. Eastern Time. The burn itself scheduled for 4:52 p.m. Eastern Time as Orion settles into that distant retrograde orbit in the midst of its long journey away from Earth, past the moon, and a return that will lead to its splashdown in the Pacific Ocean on December 11th. So we'll see you later for our coverage of Orion's next step on human exploration to the lunar surface. But for now, this is Mission Control Houston.
So you want to visit a black hole. You've packed your bags, you've updated your passport, and you're basically ready to jump on a spaceship and blast off. However, before you do that, I have just one piece of advice. Don't. Okay? If you really must go, I suppose you should at least know a few things about black holes before you leave. First, you should know exactly what a black hole is. A black hole is a physical object in space, just like everything else. It's made up of a tiny but massive point where gravity and density are infinite, a line beyond which everything, including light, can only fall into that tiny point, and sometimes some glowing stuff orbiting around it, and maybe some radiation. So basically, here is kind of bad, here is really bad, and here is safe. Also, black holes mostly come in two sizes. Don't ask me why, we still aren't sure. However, a black hole is also not a lot of things. It is not a hole, a cosmic vacuum cleaner, a portal to another dimension populated by unicorns and space potatoes, and absolutely not a good place to vacation. Okay, fine. I guess next you'll need to know how to find a black hole. Though technically black holes could just sneak up behind you, they likely won't. The nearest known one is 3,000 light years away anyway. However, if you were to go looking for one, there are a couple of good ways to find them. First, black holes tend to mess with their environment, so you can sometimes use interesting clues, such as a bunch of stuff orbiting what appears to be nothing. And second, as we mentioned before, there's often glowing stuff orbiting around them, caused by, well, when things get too close. So now that you've found a black hole and clearly aren't listening to me saying not to go, it's time for a few important safety considerations. First of all, the good news is that as long as you stay far away, black holes aren't all that bad. However, as you get closer, you need to keep a few things in mind. The radiation near the black hole can be extremely deadly. The chances of escape get slimmer the closer you get. And if you get close enough, you now have to worry about being stretched into a giant noodle and time getting really weird. So, unless you have great radiation shields, a faster-than-light spaceship, or you're completely indestructible, you should probably just stay away. Well, that pretty much sums up black holes, at least before things start getting really complicated. But before you go for real, please refer to the handy brochure in your spacesuit pocket, since there's quite a bit to remember. Now then, remember your tickets, enjoy your trip, and please, be careful. Now that you've learned about the basic solitary black hole, let's start talking about some fancier ones. While black holes themselves are indeed black, they can also be a bright source of light, putting on a great show if things like gas, dust, snacks, potatoes, missing left socks, or even stars get a bit too close. Often, this stuff can turn into an accretion disk, which is basically a bunch of gas, dust, and other stuff circling the black hole in, well, a disk. Anyway, as everything spirals in, it gets super hot and causes the wonderful spectacle we see here. Black holes can also show off by launching powerful jets, which are made when some of the stuff falls toward the black hole, gets sped up to nearly the speed of light, and then gets thrown off at also nearly the speed of light. Some of this stuff, in the form of light and charged particles, can even make it all the way to planets like Earth. The most amazing thing about all this, though, is that it could actually appear as many kinds of brilliant, bright light, including lots of light we can't see with our eyes. So, if you really want to see a fancy black hole in all its glory, it could help to have a lot of different telescopes that can see all the fanciness. And now that you know this, grab as many telescopes as you can find, line them all up, and enjoy. Now, while a lot of smaller black holes enjoy spending time by themselves, others can be a bit more social. To be specific, black holes often love to dance with other objects in the universe. Sometimes the dance begins with two stars, long before the black hole is even part of the picture. Then, one day, one of the two stars goes supernova and pop! The dance continues, but with a new partner. Other times, when another massive object, like a star, happens to pass by a black hole, it and the black hole can't help but dance together. In either case, the black hole could even pull stuff off of its new friend to make a fancy accretion disk. Look at it go! And while these first two black holes have been paired up with stars, there are quite a few other potential dance partners out there in the universe. Smaller black holes have a great time dancing with low-mass stars, high-mass stars, white dwarfs, neutron stars, unicorn... Wait, what? Off you go, then. Shoo! Anyway, they can also dance with other black holes, including really, really big ones. And sometimes, when they're dancing with a giant star, that giant star can go supernova, eventually producing another neutron star, or, voila, a second black hole. And if either of those two get a bit too close to the other black hole, you could get a new, larger single black hole. By the way, did you hear that? When two black holes collide, they also produce a ton of energy as ripples in space-time. And if we have the right tools, we can actually listen to them. Amazing! Well, there you have it. Now grab your telescopes, get out there, and dance the night away. So far, we've learned a lot about smaller black holes, but why let them have all the fun? Larger, well, much larger black holes can be just as social, but their situation is a little bit different. If we take a closer look, we can see that some of these black holes really love being the center of attention. Because they're so massive, they can gather up not just a bunch of gas and dust, but also, well, friends. In fact, they can pull in a lot of company, including stars, neutron stars, and even smaller black holes. You'll often find these social gatherings in the centers of galaxies, where some of the black holes even launch giant, powerful jets into space, just like their smaller cousins. Now, what about the black hole's friends? Well, if they're far away, many of them are content to simply zoom around in a long, lazy dance. However, as some get closer, things can get a little weird. For example, if some stars get too close, they can potentially get completely pulled apart. In other cases, if the friend is a neutron star or another black hole, and if it somehow gets really close, it can get sent off on a bizarre-looking dance around the black hole, and eventually crash into, and merge with, its big companion. Of course, these are just a few examples, and depending on the size of the friends, and the black hole, things might actually, friendship. So complicated. Anyway, if you're looking for a fun night out with lots of company, grab your telescopes and look no further than these giant black holes. So now that you've learned all about big black holes, and small black holes, and social black holes, and not so social ones, you're probably wondering what's left. Well, while we've talked a lot about common black hole situations, there are always records to be broken. For example, the biggest black hole we know of is truly massive, being 40 billion times the mass of the Sun, and the smallest one could be only 2.5 times the Sun's mass. There's even a spinniest black hole that spins at over 1,000 times per second. Adorable. Next, depending on what planet you're from, there are also closest and farthest to think about. For example, if you live on Earth, the closest known black hole is about 3,000 light years away. On the other hand, the farthest known black hole is about 13 billion light years away. Although what that really means is that light from near that black hole took 13 billion years to reach us. And because the universe is constantly expanding, that means now it's, in any case, it's still farthest known. Let's move on. If you're feeling more adventurous, there are also some rarer black holes to be found, assuming some of them even exist, that is. For example, while we do know about small and big black holes, we've only found a few that fit somewhere in between. It's also possible that tiny black holes may have formed back at the beginning of the universe, when everything was just really packed together. However, even if they did exist, we definitely haven't detected them yet. And finally, we'd love to catch two giant black holes crashing into each other because, well, we just haven't seen that yet. So, if extreme adventures and rare finds are at the top of your black hole watching list, grab your rocket ship or your favorite observatory and start searching.
On January 21st, 2019, for the very first time, NASA's tests saw a black hole destroy a star. This was a tidal disruption event, which occurs when a star passes too close to a black hole. Extreme gravity causes the star to bulge and break apart into a stream of gas. The tail of the stream escapes into space, but the rest swings around to form an accretion disk. This event, called Assassin 19BT for the All-Sky Automated Survey for Supernovae, which first identified it, happened in the TESS Continuous Viewing Zone. TESS's 4 cameras scan large sectors of the sky, and one constantly monitored this region for a full year. TESS saw Assassin 19BT as soon as it started to brighten, days before other observatories spotted it. NASA's SWIFT satellite quickly observed the outburst in visible light, UV, and, along with the European XMM Newton satellite, X-rays. The UV measurements are the earliest recorded for a tidal disruption to date. They showed the event's temperature dropped almost 50% in just a few days. Such a steep decrease has never been seen in a tidal disruption before. These outbursts are rare, happening only once every 10,000 to 100,000 years in a galaxy like our own. Future discoveries will help us learn even more about these uncommon cosmic blasts.
In 2011, NASA's SWIFT satellite caught an X-ray outburst from a small galaxy 3.8 billion light-years away. Within a couple of days, researchers realized they were witnessing the aftermath of a tidal disruption event, a star ripped apart by the monster black hole at the galaxy's center. Some of the stellar material fell toward the black hole, forming an accretion disk and a jet pointed in our direction.
Tidal disruption events offer us this rare view at the most common kind of supermassive black hole in the universe, these so-called dormant supermassive black holes. 90% of black holes in the universe don't have a lot of hot material orbiting around them. They don't form these accretion disks, and so we can't observe them. Tidal disruption events, where the stellar debris causes the formation of a temporary accretion disk, offers us a way to probe this population of supermassive black holes.
SWIFT monitored the outburst's progress and was joined by the European Space Agency's XMM Newton Observatory and the Japanese Suzaku satellite. Recently, astronomers introduced a new analysis technique that for the first time allows them to peer deep into the gravitational well of a normally quiescent black hole. Called X-ray reverberation mapping, The method charts the region close to the black hole using light echoes from X-ray flashes, similar to the way sonar uses sound to map the ocean floor.
X-ray reverberation mapping has been very successful at probing the accretion flow in well-established accretion disk structures, but had never been used to look at tidal disruption events. My collaborator at the University of Maryland and I were having lunch one day, and she says, "Has anyone ever looked at tidal disruption events with X-ray reverberation mapping?" That night, I stayed late at the office and just tried it out on this data from Swift J1644, and much to my surprise, the result was amazing, and I could see that we were looking at the structure of the inner accretion flow around a normally dormant black hole for the first time. It's not like a normal accretion flow in an active galaxy that's a flat disk. This is something that is extremely puffy, very turbulent, and we are measuring flashes of X-ray emission deep within this newly formed accretion disk.
Stellar material streamed into the developing disk, churning it into a thick, chaotic whirlpool of X-ray emitting gas, funneling toward the central black hole. Deep inside this cavity, multiple X-ray flares erupted, providing a flash that echoed throughout the region.
Previously, astronomers had thought that the X-ray emission is coming from far out in a jet. But what we're finding with these observations is that the X-ray emission is coming from flares very close to the supermassive black hole. And we can use these observations to probe properties of the black hole itself. For instance, we found that the mass of the black hole is something on the order of 1,000,000 times the mass of the Sun.
The first observations of X-ray reverberations from deep inside an accretion disk are providing new insights into a rarely observed class of black holes. They're also laying the groundwork for a better understanding of tidal disruption events and the black holes they illuminate.
The space between stars holds an array of vibrant clouds. Clouds that command our attention. Clouds that create spectacular displays. Clouds that seem familiar, tenuous, and fragile. Clouds that hold clues to star birth and death. NASA's Hubble Space Telescope has imaged hundreds of them in extraordinary detail. These vast swirls of gas and dust get their name from the Latin word nebula, meaning cloud or mist. Nebulae is the plural of nebula, and they come in a wide range of shapes, sizes, and forms. Emission nebulae are some of the most spectacular. These opaque, gleaming clouds of gas and dust radiate or emit their own light. Ultraviolet light from nearby stars energizes atoms in the cloud. When the excited atoms lose that energy, they release the light that gives emission nebulae their glow. The Orion Nebula is one of the most famous emission nebulae. Its core, called the trapezium, holds 4 enormous young stars whose ultraviolet light powers the region's intense glow. The Carina Nebula is another vast emission nebula and star-forming region in our galaxy. Within the nebula is a pillar 3 light-years tall, dubbed Mystic Mountain. It cloaks massive young stars, some with jets emerging from the cloud. Hubble's infrared view cuts through the shroud of gas and dust, revealing these radiant jewels. Reflection nebulae shine by the reflected or scattered light of nearby stars. They often have a bluish color because the dust grains in the clouds scatter blue light more efficiently than red light. Not all nebulae shine brightly. Dark or absorption nebulae are inky black clouds of gas and dust that block the light coming from objects behind them. Because they are dark, absorption nebulae are hard to find. We only see them as silhouettes against a much brighter region of space. Most large nebulae are a combination of emission, reflection, and absorption nebulae. Their dark dust lanes may give birth to new stars that provide the light needed to illuminate the cloud. Planetary nebulae are a type of emission nebula powered by a small to medium-sized dying star. As these stars run out of fuel, they periodically blow off their outer layers. The expelled gas expands outward away from the star, forming a bubble or shell around the star. Sometimes, the envelope of debris holds clumps of dense gas that shine like the gems of a necklace. The term planetary nebula is misleading. It comes from late 18th century astronomers who thought their rounded shape looked similar to planets and telescopes of that time. They named them planetary nebulae as a result. Supernova remnants are the diffuse clouds of expanding debris released by a massive star's death explosion. The Cygnus Loop is a vast, expanding, 110 light-year-wide supernova remnant. It is so large that Hubble can only image small sections of it at a time. Some supernova remnants emit their light from a shell of shocked material. Others, like the Crab Nebula, emit most of their light from within the expanding shell. And still other supernova remnants shine as a combination of the two. Nebulae are some of the most resplendent objects in the universe, and thanks to the Hubble Space Telescope, we can study them in all of their magnificent forms.
Every day or two, on average, satellites detect a massive explosion somewhere in the sky. These are gamma-ray bursts, the brightest blasts in the universe. They're thought to be caused by jets of matter moving near the speed of light associated with the births of black holes. Gamma-ray bursts that last longer than 2 seconds are the most common and are thought to result from the death of a massive star. Shorter bursts prove much more elusive. In fact, even some of their basic properties were unknown until NASA's SWIFT satellite began work in 2004. Astronomers suspected that crashing neutron stars could explain short bursts. A neutron star is what remains when a star several times the mass of the Sun collapses and explodes. With more than the Sun's mass packed into a sphere less than 18 miles across, these objects are incredibly dense. Just a sugar cube-sized piece of neutron star can weigh as much as all the water in the Great Lakes. When two orbiting neutron stars collide, they merge and form a black hole, releasing enormous amounts of energy in the process. Armed with state-of-the-art supercomputer models, scientists have shown that colliding neutron stars can produce the energetic jet required for a gamma-ray burst. Earlier simulations demonstrated that mergers could make black holes. Others had shown that the high-speed particle jets needed to make a gamma-ray burst would continue if placed in the swirling wreckage of a recent merger. Now, the simulations reveal the middle step of the process, how the merging star's magnetic field organizes itself into outwardly directed components capable of forming a jet. The Damiana supercomputer at Germany's Max Planck Institute for Gravitational Physics needed 6 weeks to reveal the details of a process that unfolds in just 35 thousandths of a second. The new simulation shows two neutron stars merging to form a black hole surrounded by superhot plasma. On the left is a map of the density of the stars as they scramble their matter into a dense hot cloud of swirling debris. On the right is a map of the magnetic fields, with blue representing magnetic strength 1 billion times greater than the Sun's.